Hi guys, how's it going? Hope everybody's doing well. We are going to go over the free fall problems and the problems on page 232. Okay, so we've already got the first couple here. Go ahead and let's look at those. Let me get all my wires out of the way. Okay, so we've already done these, but if you need to look at them again, they're right here. So you can pause the video if you need to and take a look at those. But I want to go ahead and start on the third one. Okay, so that says a skydiver jumps from a helicopter hovering at high altitude. If we ignore the air resistance, how fast would she be falling 2.2 seconds after jumping? Okay, so let's look at our givens. Make sure you guys can see me. Okay, so we're going to look at our givens. We have 2.2 seconds is our time. And then our acceleration, or little g, is 9.8 meters per second squared. And it's asking for velocity, or how fast. Okay, so if you remember, we have our formulas up here. We have our formulas up here where it says v equals at. That's with regular acceleration. And then v equals gt is with gravity, so free fall. Okay, so we're going to use v equals gt. Okay, then you're just going to multiply those together. All right, so you've got 9.8 times 2.2. Okay, so let me get my handy dandy calculator. And I've got 21.56. Okay, 21.56 is my answer. Now, it's the velocity, so I have to put my units. So it's going to be meters per second. Okay? So it's 21.56 for number 3. Okay, so let's do number 4. That is, what vertical distance will a penny fall on Earth in 12 seconds if it's dropped from rest? Okay, we're going to ignore air resistance. You haven't learned about that yet, so it doesn't matter. Okay, so when we're talking about vertical distance, we're talking about free fall again. So we have number 4. Our givens are gravity, is 9.8 meters per second squared. And then it gives you this time is 12 seconds. And then it's asking for distance. Okay, so we only have the 2 formulas. I'm sorry, I'm switching between screens if you're wondering what I'm doing. Okay, so you only have the 2 formulas. You've got velocity, and then you have distance. And those are the only 2 formulas that we're using on this sheet. Okay, so we're going to be using d equals 1/2 gt squared. Okay, so we have that. We know that we're looking for distance, and we have g and t. Okay, so let's go ahead and plug it in. We have D equals 0.5, which is the same thing as 1/2, times 9.8, times time, and that's 12 seconds, and that's squared, okay? So then we're going to go ahead and square that. D equals 0.5, 9.8, and 12 times 12 is 144, I believe. Okay, then we're going to go ahead and multiply all that. That's times 0.8 times 0.5. All right, so I got 705.6. Let me double check it. Yes, 705.6. So, okay, and it's looking for distance. So that's going to be in meters. Okay. Now let's go ahead and go to number 5. Whoops, that's already got something on it. Let's go ahead and go to number 5. We have Kenny Klutz drops his physics book off his aunt's high-rise balcony. Well, that was very irresponsible of him, wasn't it? It hits the ground below 2.5 seconds later. Okay, the first thing is, what is the speed? And the second question is how high? So we're going to be using both of our formulas on this. So let's go with 5A first. Okay, let's make sure you can still see me. Okay, 5A, we're going to put down what we know. The aunt's high-rise balcony, we don't know how high it is yet, but we're going to get there. The time is 2.5 seconds. And then you have gravity, 9.8 meters per second squared. And it's asking for velocity. Okay, so we're just going to do our V equals G times T. Okay, because that's the only formula we're using on this sheet. So you've got 2.5 times 9.8. Okay, let's get my calculator out. 2.5 times 9.8. And that's 24.5. And because it's velocity, that's going to be meters per second. Okay, so that's 5A. Okay, now we're going to go to 5B. And that one is asking how high. So we already have everything we need. We want to know the distance. Okay, how high is always distance. So we're going to use D equals 1/2 GT squared. All right, so you have 0.5, then you have 9.8, then you have your time, which is 2.5, and that's squared. Okay, so we've got it plugged in. Let's go ahead and get it going. Times. Okay, and I got 30.625. Let's do that one again so that we know if it's right. Okay. Went through it again. All right. 30.63. Let's just round that. And that's going to be, because it's distance, it's going to be meters. Okay, so that's 5B. All right, now the reason I know the units is because of what it told me in the problem. If the problem is talking about meters per second, then you know that your time is in seconds and your distance is in meters. Okay? If you have meters and seconds and you're looking for velocity, it's meters per second because it is on the other two. So it all has to match unless it tells you otherwise. So be really careful with that. Okay, let's look at the next one. All right, that is going to be, get that window out of the way. All right. Number 6. You drop your pencil from the desk and it hits the floor 0.45 seconds later. A, how tall is the desk? And B, how fast is it going? Okay, so we're going to go ahead and put this up a little bit. Oops. So you can see. All right, so you have your time. Let's see, this is number 6. Your time is 0.45 seconds. And gravity is 9.8 meters per second squared. Okay, and the first thing it's asking is how tall. Okay, how tall means we're looking for distance. Okay, so we're looking for distance, so that's going to be 0.5. I'm sorry, distance equals 1/2 GT squared. That's my formula. All right, so I'm just going to plug it in. G is 9.8. Time is 45 seconds squared. Okay, so let's go ahead and plug that in. Okay, let me try that one again and make sure. I think I hit something wrong on that one because that doesn't look right. What I'm doing, guys, is the same thing you should be doing. I'm giving it a sanity check. Okay, so the first thing I got was over 9,000. Okay, so I know that that's not right because it's off a desk. Okay, so that cannot be right. So let's redo it. And that is going to be 45 seconds squared. Okay, and then you have times 9.8 times 0.5. Okay, so I got I see. It's 0.45. That's the problem. It's 0.45 seconds. I guess 45 seconds would be a lot. Okay. There's my sanity check. I'm trying to figure out what I did wrong because it's over 9,000 and that's not right. Okay, so we have 0.45. times 9.8 times 0.5. Okay, there we go. 0.99. We're going to go ahead and just round that. So it's going to be 0.99 meters because it's distance. Okay. Okay, so be careful, guys. Know that you need to do a sanity check. You know it's coming off a desk. It's not 9,000 meters. It's just not possible. Okay, then the next thing is how fast. Okay, so we're going to go with velocity equals gravity times time. Okay, so you still have gravity and time up here. So we've got gravity is 9.8 and time is 0.45. Okay, then you're just going to multiply those. Okay, and I got 4.41. And because it is velocity, that's going to be meters per second. Okay, and that should be 6B. Okay. Now, the next one, number 7, let's go ahead and go on the back for that. Oops. Let's go ahead and go on the back for that one and make sure that we have enough space. Okay, so you have Mars has an acceleration due to gravity of 3.47 meters per second squared. Now the negative, don't worry about that right now. The negative just tells you direction. So don't worry that it says negative. It says that with 9.82. So 9.8 meters per second squared is only on Earth because of the gravity on Earth. The gravity on Mars, the gravity on the moon, they're all different. Okay. So if you ever see people on, video of people on the moon, they're jumping around really slow because the gravity is not the same. So this one says Mars has an acceleration due to gravity of 3.47. And that's meters per second squared. Okay. And it says, what speed is when a quarter is dropped in 1.5 seconds? Okay, so that's your time is 1.5 seconds. And it's asking you how fast or what speed. Okay, so the one that we're going to use, the formula is V equals GT. Okay, same formula we've been using. Then we're going to go with plugging it in. So it's 3.47 times 1.5. Okay, so let me plug it in my calculator. Okay, so I got 5.205. So let's round that to 5.2. And that's meters per second because that is velocity. Okay, so that was A. This is 7A. And 7B is asking how fast would it be falling on Earth? Okay. So you've got on Earth, gravity is 9.8 meters per second squared. And then you still have the same time, 1.5 seconds. Okay, so then you're just going to plug it in the same way. V equals GT. You're just using Earth's gravity. Okay, this was Mars gravity. Okay, this is Earth. Okay, so let's just plug it in. V equals 9.8 times 1.5. Let's plug it into my calculator. Okay, and I got 14.7. So I know that velocity is 14.7, and that's meters per second, and that is on Earth. Okay, so on Mars, it's going to fall slower because the gravity is not pulling as hard because the gravity is not as much, as Earth is 9.8, Mars is 3.47. So the velocity is higher on Earth because it's pulling more. Gravity is pulling more. Okay, let's go to the next one. And this one's on the moon. So this one's going to also be very similar to the one we just did. Okay, so 8A is on the moon. A freely falling object has an acceleration due to gravity of 1.6 meters per second squared. Again, do not worry about the negative. That's something that you'll see in physics. Okay, so this is the moon. So you have, if you were to drop a penny, how far will it fall in 1.8 seconds? Okay, so my time is 1.8 seconds. And I want to know how far. Okay, so this is distance. Okay, so be sure and read it correctly so that you know what you're looking for. Okay, so let's go ahead and use our formula. We've got D equals 1/2 GT squared because we're looking for distance. And then we're just going to plug it in. 0.5 because that's the same as 1/2. G is 1.6 and time is 1.8 squared. Okay, now if you remember on another video, I was having trouble with the square on my calculator, so be really, really careful when you do it. I like to just do the square first because my calculator kind of doesn't like it that if I do it the other way. So it's just whatever works for your calculator. So be really careful with that. Okay, so let's go ahead and put it in. Times 1.6.5. Okay, I got 2.592. Okay, so let's make that 2.6. And that's in meters. Okay. Now on the second one, if you dropped it on Earth, how far would it fall? Okay, so let's go ahead and do Earth again, like we just did. 8B, this one's Earth. So you have gravity is 9.8 meters per second squared. And your time up here is 1.8. So let's bring that down so we remember it. Okay, 1.8 seconds. Sorry, somebody's dinging me. Okay, and then I still want to know distance. Okay, so let's go ahead and put distance here. So let's look at our formula. D equals 1/2 GT squared. So we're going to plug it in. 0.5, 9.8, and 1.8 squared. Okay, so let's go ahead and plug that in. Okay, and I got 15.876. Okay, so let's go ahead and make that 15.9. Okay, and that's going to be in meters. Now, why the difference in distance? I can see the difference in velocity, but why do we have a difference in distance based on gravity? Well, think about if you are pulling a cart, okay? If you're pulling a cart, if you pull it really hard, it's going to go further in less time. If you don't pull it very hard, it doesn't go as far in the same amount of time. So it's the same thing with gravity. Gravity on Earth is pulling harder. So it's 9.8 meters per second squared in a particular time per 1 second. So it's 9.8 meters per 1 second. All right, this one is 1.6 meters in 1 second. Okay, so that's your difference. Now let's look. Is that the last one? Okay, we already did the one with the free fall. If you want the answers to that, go ahead and send me a text and I'll do that. I think we pretty much got it right when we did it before. So I'm not going to go through that unless you just want me to. Okay, and I can send you the answers for that if you want to ask me for them. Now, the questions on page 932, I'm sorry, 232. This was in your book. These were the application problems in your book. So let's go over those and make sure that we've got everything we need. The first one, you have a safe free fall for 7 seconds. How far does it fall? Okay. So again, we've got D, we don't know. 7 seconds is our time. And then we know gravity is on Earth. It's 9.8 meters per second squared. Okay, so then we're just going to plug it in. We're looking for distance. So it's going to be D equals 1/2 gravity times time squared. So D is 0.5 times 9.8 times 7 squared. Okay, so let's go ahead and plug that in. Okay, and I got 240.1. Okay, so I've got the safe goes 240 meters. Okay. All right. So let's go with number 2. A marble is dropped a distance of 78.48 meters. Let's go ahead and write that down. Okay, 78.48 meters. And how long does it take to fall? Okay. All right, so we need to know, oh, it wants to know time. Okay. So you have to read it right. You don't know time, and then you don't know anything else. Oh, you know gravity. Okay? So it's asking you for time. All right, so this one's a little tricky, but you're still going to do d equals 1/2 gt squared. Okay, and we're going to just go ahead and put it in like this. 78.48 is equal to 0.5 times 9.8 times t squared. Okay, now that's kind of a booger bear. You got to be careful with it. So if you go ahead and put it in like that, that's going to be harder. So we're going to switch everything around. And let me go ahead and just give this to you. You're going to end up with t squared is equal to 2 times 7848 over 9.8. Okay, and that's kind of weird. I'm not gonna do this to you on a test. And then you're gonna end up with about 16 seconds squared. So then the square root of 16 is 4. You're gonna end up with 4 seconds. If you really are into algebra, I'll go ahead and try that on your own, but I'm probably not going to put that on a test because that's a bit much. Okay, number 3. You have the marble in question 2 has a mass of 2 grams. Okay, what's the weight in millinewtons? Okay, so for weight, this is a little different. Weight is the force of gravity or the force of weight, and that's mass times gravity. Okay, we haven't really talked about this a lot, but if you remember in the notes, we did talk about it just a little. So you're looking at mass times gravity. So mass is 2 grams. You have to convert it to kilograms because it's asking you for millinewtons. Okay, so 0.00200 kilograms. All right, then you have your force of gravity or weight is 0.00200 times 9.8. Okay, so if you want to work that out, it's going to be 19.6 millinewtons. Okay, so if you really want to get into it, you can try that one. That one's a bit much. I'm probably not going to give you that either. Okay. Now let's try this. Try number 4. You have a man weighs 784 0.8 newtons. Okay, so that's your mass. 784.8 newtons. What's his mass in kilograms? Okay, so you're looking for force of gravity, or weight is mass times gravity. Okay, so you have 784.8 newtons equals mass times 9.8. Okay, and you throw that around with some algebra, and that is going to be 80 kilograms. Okay, so if you got lost on these last couple, it's okay. We're not going to do those on a test, but if you did these problems, you need to know the answers. Okay, so go ahead, you can go back and pause the video if you're not sure about something. One more time, the ones that have the really complex algebra, I'm not going to give you on a test, so you can relax. Okay, so go ahead and do that, and we'll talk to you later. Bye.